We all know how important grain direction is for a book, but what about for boxes and enclosures? Is it important, and what is the correct grain direction? It's not quite as simple as a book, but once we consider the mechanics, there is usually a best option. In this video, I'll look at basic boxes and construction approaches and discuss the pros and cons of different grain directions, leading to the best options. When I want to know something about bookbinding, I go to Johnson. Let's see what he has to say on this subject. In the section on slipcases, he says of the individual pieces of board, all pieces are long grain and each is lined with a pasted, good quality toned paper. But he doesn't explain why they should be long grain. Maybe a quick recap on grain and the impact of moisture is in order. All cellulose fibre machine-made paper, card and board material used in bookbinding has a grain direction. Okay, I'm sure there's some exotic materials I haven't thought of or don't know about that breaks the rule. You can impress me and put a comment below, but let's assume we're dealing with common materials with a grain. Cellulose fibre is a long skinny thing that is bound together by magic, sticky tape or hydrogen bonds or something. Let's keep pesky chemistry out of this. These materials are made by pulling a mesh under a long waterfall of cellulose pulp, which results in the fibres being aligned roughly in the direction of motion of the mesh. The direction of alignment of the fibres is the grain direction. Cellulose fibres are just like me when I drink beer. I don't get any taller, but I definitely get wider. When cellulose fibres are exposed to water, they expand, but they don't get longer, or maybe only a little bit. This means when a piece of paper is glued out, it expands perpendicular to the grain direction. At first, this happens on the side of the paper that is glued. The wet side of the paper expands and causes the paper to curl. After a short time, the moisture absorbs through the paper until it's evenly moist, and the paper goes flat again. When this happens, we say the paper is relaxed. Now it's slightly larger, perpendicular to the grain direction. The other important physical characteristic of material with a grain direction is that it folds or bends easier parallel to the grain direction. This is the usual test for determining grain direction. I've got an imperfect analogy, but I hope it helps you remember this characteristic. It's like a sushi rolling mat. Lengthways, the pieces of bamboo are quite rigid, but the mat bends and rolls easily in the other direction. Looking around for other advice on the subject, the Hollanders in their book Introduction to Bookbinding in Custom Cases say, you want to cut your board pieces with grain long because it produces a more solid structure. They're suggesting the property of board bending less in the grain direction means the walls will be more rigid in a tray or box constructed this way. In his book, A Comprehensive Guide to Box Making, Roger Green gives a more detailed and thoughtful analysis. For a start, he considers both the underlying board and any cover material or other lamination. He suggests, if possible, the covering materials should follow the same principles as the underlying boards. The reason he says, if possible, is that there are circumstances where it's not possible. A good example is covering a tray or lid with a single piece of paper covering the base and folding down onto the sides. On two sides, the grain will match the board, but on the other two it will not, and this can't be avoided. I'll talk about the consequences of this in a bit. I sometimes see people recommending that board be cross-laminated to make it more rigid, like in plywood. I'm very much against this approach. I've experimented with this, and my experience is that you end up with a board that warps in all directions, even diagonally. It's better having a material behave in a way that you can predict and manage. An excellent point that Roger makes is that any box with a hinge, such as a hinged lid, should have the grain direction running parallel to the hinge. Otherwise, any warping of the board at the hinge can damage it. Luckily for most hinged lidded boxes, this is consistent with the next recommendation. Roger suggests the grain direction should run parallel to the open edges. This way, any expansion and contraction is in the height of the box and not towards the corners, which could damage the structural integrity of the box. I've always considered this the most important consideration, and for this reason I've always said the walls should always be long grain. I had not considered the less common case of deep boxes when the height of the wall is more than the horizontal directions. In this case, the best grain direction is short grain. It's still running in the same direction, parallel to the open edge, just that the box dimensions now make it short grain. We've considered the walls. Now what about the base of trays or top of lids, or sides of slipcases? You can't have the grain running in both directions. One direction will produce forces outwards on the box. The answer is to minimise the absolute expansion, and that is done by using long grain. The expansion is the smallest this way. Roger mentions one significant exception. In round boxes, you want the side or walls as pliable as possible to make it easier to bend. This is best achieved by having the grain direction vertical or perpendicular to the opening edge, the opposite for boxes with straight sides. Roger Green has by far the most detailed analysis of grain direction in box making of any of the books I've checked. This is a reflection of the quality of this book, which I've reviewed for my Patreons and highly recommend. Compare this to the popular book called Cartonnage Basics and Beyond, where I saw no mention of board grain direction. These guidelines are easy to apply when the box is made of individual pieces of board glued together. In these cases, you have control over the grain direction on each side or piece. But it's also common to make boxes by scoring and folding board. Assuming the base has been cut to be long grain, then the two short walls will have grain perpendicular to the edges. This can't be avoided, and it's the best scenario with the least absolute amount of potential movement. Okay, to summarise, in dealing with grain direction in boxes and enclosures, always preface everything with if possible or when practical. For the walls, have the grain run parallel to the open edges, which is usually long grain. For the base or top, cut the board long grain to minimise the absolute amount of possible movement. Covering and laminating material grain direction should match the board grain direction. When covering from the top or base with a single piece that extends down the sides, on two edges the grain direction will be perpendicular to the edges. Try and arrange it so these sides are the shortest. When making a box by folding the edges, two walls will have vertical grain. Try and arrange it so these are the short edges. This is done by making the base long grain. You've just spent the last 10 minutes listening to me tell you about the importance of grain direction in box making. Yet, as I mentioned, there's a very popular book on the subject that doesn't even mention grain direction. I suspect you could ignore the subject completely and make simple boxes with no problems at all. But it is something that's easy to manage, and so why not? And this will give your constructions the best chance of surviving decades or even centuries. Box making is simple once you know the basics. From these basics, you can quickly go from making simple lidded boxes to nested trays, clamshell enclosures, to boxes with more complex angles than right angles. As you get more materials laminated together and more complex geometries, this is when grain direction is likely to be more important. Now you're equipped to manage it. Until next time, cheerio.